right, so we're going to go ahead and finish up these last 4 problems now in the Google slide that has the practice problems. Okay, the first rule we are going to look at is this one right here. It's the bottom row on the first page of the notes that I put in the hyperdoc. This one has intersecting secants, which are lines that go all the way through the circle. And here they're intersecting on the exterior, meaning outside of the circle. So right here where that vertex A is at. So this rule says that if we focus on this DE, which is this little arc measure here, and we subtract from that this little arc measure here, BC, and then we divide it by 2, that will give us the angle A right there. Okay, let's look at number 7. For this one, we are trying to figure out first what this angle is, the measure of BDA. So as I'm looking at this, I'm going to kind of draw this out. This is my angle. And remember, this is just an inscribed angle. We did this rule on the first day. And we know if we can figure out what this arc measure is here, we just divide it by 2, and that gives us this angle. So if this whole thing is 250 degrees, that's a central angle, which means that this whole arc measure out here is 250. If all the way around is 360, then I can take 360 and subtract the 250, and I get 110, which means this measure here is 110 degrees. So if this is 110 degrees, I'm going to divide it by 2, and that'll give me that angle measure there. That's 55 degrees. So this first piece here is 55 degrees. The second part of this problem, we want to figure out what angle BCA is. So I've kind of drawn this out. This is the rule that I just went over first at the beginning of this video. So for these secants that are intersecting on the outside of the circle, if I know this arc measure here, which I do, it's 250, and I know this arc measure here, which is 110, then I can find that angle measure by taking this arc measure, subtracting the 110, and dividing by 2. So that's what we do for this one, and our answer is going to be 70 degrees. All right, we have another rule to look at here. On your rule sheet, it's in the 3rd row on the bottom. We're going to look at this one here, right on the right. The actual rule is played out the same way that this rule was, but the difference here is that these are intersecting tangents on the exterior. So we talked about a tangent's a line that just touches the circle in one place. It's like touches the outside part of the circle in one place. So when these tangents intersect on the exterior, meaning outside the circle, we're going to take this arc measure here, and we're going to subtract that arc measure right there, and then we're going to divide it by 2. So the rule is just like what we did here. It's just set up a little bit differently. So looking at number 8, we have the situation like I just discussed in the rule. So these are tangent lines, and they're intersecting outside the circle or on the exterior. So if this arc measure is 250 degrees, just like the last problem, we said all the way around is 360. We're going to subtract the 250. That means this is 110. Then we use our rule, which says this arc measure, which is 250, minus this arc measure, which is 110, divided by 2 gives us this angle right here, and our answer again is 70. Okay, here we have number 9. So for this one, they tell us that DG and EG are tangent to circle C and F. So that means that these 2 lines right here, these are tangent to both of these circles. And the points of tangency are also given. So it's A, B, and D, and E. So those are the exact points that they're going to intersect those circles. Whenever you have this scenario and you've got 2 circles sitting within the same 2 tangent lines, coming out to those points of tangency, these angles are going to be congruent. So if this is 140 degrees, this one is also 140. All right, this is the last rule we're going to look at. This is intersecting chords on the inside of the circle. Now we're going to switch here. We've been talking about angle measures and arc measures, and this rule is talking about the length of these pieces within the chord. So the rule says that this length A times this length B is equal to this length C times that length D. All right, we're on number 10. This is our last one. So here we have the diameter, which is AC, And then we have another chord, which is BD, and they're intersecting at point E. So here we're going to focus in on length. So remember our rule is this piece here, DE, times this piece here, EB, should be equal to this AE times this AC, this whole thing here. All right, so we go off of where they intersect. So we basically just need to fill in the lengths that we know and then solve for the one we don't. The one we don't know is going to be BE. So I'm going to call that X. So as I look through, they tell me that AE is 2.5. So this little piece here is 2.5. All right, they also tell me that DE is 3.4. So I'm going to put 3.4 right here. And then they tell us that the radius is 5. And that's the only kind of tricky part about this problem. So the radius is 5, which means that here OC is 5 and this AO is also 5. So that means that if this is 2.5, then 5 minus 2.5 would be 2.5. That means this little piece here is also 2.5. And then this radius here is 5. So as we're looking at these chords as they're intersected with E, that means this is 2.5. This is 2.5 plus 5. So that means that whole thing there is going to be 7.5. This is 3.4, and that's X. So we're going to take these values here, and we're just going to solve them algebraically. Okay, so to go ahead and step through this algebraically, we take the two segments A times B and set it equal to C times D. I plugged in those lengths that we just talked about. If you're unclear where those values came from, just rewind here a little bit and check to make sure you know where they came from, and we solve for X. X is equal to 5.514. The question says, what is the approximate length? So we're going to go ahead and take our rounded value of 5.5. Okay, that wraps up the practice problems. Again, make sure you go back and do these problems on your own so that you are prepared for the mastery test.